Welcome to your new unit. So we are doing a pretty short unit of just a little bit, basically what's left of R, I think. But today we are focusing on R7. I checked. It's R and 1 that we're focusing on in this unit. So we're still combining things. But this is R7, which is rational expressions. So let's talk about what a rational expression is. We've seen rational expressions. We've been dealing with them last unit with domain. So a rational expression is a ratio of two polynomials, primarily a polynomial with a variable in the denominator. So if you look down here, notice how every single one has a variable in the denominator. The domain of a rational expression, this is something should be review, is all real numbers except those that make the denominator equal to 0. So make the denominator equal to 0. So an example of a rational expression, even though we have a plethora of examples down there, is when we have a polynomial on top, so x squared plus 5x minus 8, it could be x, it could be 2, it could be 5x, but what's most importantly is the variable in the denominator, so 3x plus 2. So for it to be a rational expression, it needs to have that variable in the denominator, and that is a rational expression. So first thing we're going to do is reducing rational expressions. I actually am a super nerd, and I love reducing rational expressions. It's like a puzzle. I like to simplify. It brings me joy. So here we go. When we are doing it, so I've written the steps. We're going to do an example with it, and then we'll do some more practice. When you are simplifying or reducing a rational expression, the first thing you want to do is completely factor the numerator and the denominator. So I'm going to kind of color coordinate this. We usually write out every single step, but making a video of that was going to be entirely too long, so I made guided notes. Yay, us. So on the top, and I should emphasize this, factoring in this is going to be huge. If you are at any point uncomfortable with factoring, you need to go back and you need to watch the R5 video of factoring, because if you don't know how to factor on this, it is going to be rough. So please go back and watch that R5 video, watch some Khan Academy videos, but make sure you're being proactive and you're factoring and understanding how to factor. Okay, so 4x minus 16, I look to see how I can factor that, and I can factor out a GCF of 4, and then I have x minus 4. And then x squared minus 16 is a difference of squares, so I would factor that to be x plus 4 and x minus 4. So that's my first step, is just to completely factor the numerator and the denominator. Now my second step is to cancel any like factors. So that's super important too. And I put factor like in caps, it's underlined, it should be like an exclamation point. A factor is something that is exactly the same. So we have x minus 4 and x minus 4. They both are two terms. First term is x, second term is minus 4. Those are the exact same factors. I cannot cancel like up here. I can't just cancel the minus 16 and the minus 16. The reason why is because that entire expression, 4x minus 16, is not the same expression as x squared minus 16. It's super important that you understand x minus 4 and x minus 4 are like factors, and that's what can be canceled. And so now there's nothing else further I can cancel. I know some of you guys are like, what about the 4 and the 4? Again, this factor is x plus 4. For us to be able to cancel something, it has to be exactly the same. X plus 4, this is just the plus 4. So I can't just cancel those. So my final most reduced answer is 4 over x plus 4. A like factor is something where you can put it in parentheses, right? So I can't just put this 4 in parentheses and cancel that out. But I can put x plus 4 in parentheses. If I had an x plus 4, then I can cancel that out. Just like I canceled out x minus 4 and x minus 4. So that's my final answer. Okay. What's really important and something that I want you guys to do with all of your answers for reducing, multiplying, dividing, adding, subtracting, I always want you guys to leave your answers fully factored. So always leave your answer fully factored. Do not multiply it back together. You can. It's extra work, and it's unnecessary to me. So do not multiply back together. Like I said, you can. It's just more work and another area where you could possibly make a mistake. So I would rather you to not do that. Okay, so let's look at number 2. First step, completely factor the numerator and the denominator. So I want you guys to, on your own, factor top, factor bottom, come back, check to make sure that you factored it correctly. Okay, so I factored mine. X squared plus 12x plus 27, my two numbers that multiply together to get me 27 and add to get me 12 are 9 and 3. And then the bottom is a difference of squares. So now that I've completely factored the numerator and the denominator, I look to see, are there any like factors? And there are. X plus 9 is exactly the same as x plus 9, so I can cancel those out. And I am left with x plus 3 over x minus 9. I cannot simplify any further. 3 and 9, I know some of you guys are tempted to do that. Again, you can't just put the 3 in parentheses and the negative 9 in parentheses and cancel. This is an entire expression, x plus 3, and an entire expression, x minus 9. They are not exactly the same. We cannot simplify this further. That's my final answer. Okay, so let's look at 3. We have x squared plus 2x minus 24 and 4 minus x. Now, before I let you guys try this one on your own, I want you guys to look at the bottom. The bottom is written a little different, right? We have 4 minus x, where we typically have the variable first and the number second. So let's actually rewrite that to help us. So we're going to keep the top the same. But I'm just going to rewrite this so it's negative x plus 4. I didn't change anything. I just reordered it. So my variable is first and my number is second. Okay, so what I want you guys to do is factor the top on your own. So factor the top on your own. So I factored the top. My two numbers that multiply together to get me negative 24 and add to get me 2 are 6 and negative 4. And the reason I left the bottom as is because what I'm actually going to do, if you look, this negative x plus 4 and x minus 4 is kind of similar. And so what I'm going to do is actually factor out a negative 1 from the denominator. So if I factor out a negative 1, I'm left with x minus 4. And so now, are there any like factors that I can cancel? And there are. X minus 4 and x minus 4 are exactly the same. I can cancel them. And now I'm left with x plus 6 over negative 1. Now, that's one way of writing it, not the most correct way of writing it, but you can write it as instead negative times x plus 6. Because 1 over negative 1 is the same as negative 1 over 1. So really, these are exactly the same. Okay, so that's reducing. We're going to use that in our multiplication and dividing as well. So we're going to move on to that next section. Multiplying and dividing is really similar to reducing. It's just like a little bit extra steps. So I'm going to first deal with this one. I made like the first one that we do together a little bit more challenging because it involves everything. And then we'll kind of tailor it back a little. Okay, so your first step with dividing only, that's super, super important. With dividing only, no, wrong color. So with dividing and only with dividing, so not multiplying, just dividing. In normal situations, we want to take the reciprocal of the second fraction and multiply. It's just like if we were doing like a normal fraction. So if I had like 3/4 divided by 1/5, to get that you would multiply the reciprocal. It's the exact same. So we're going to actually start with that step. Before I start with that step, I have a fraction over a fraction. We've seen this just with numbers. Now we're going to rewrite this to make this easier on ourselves. So the top, 12x over 5x plus 20. Remember, this is just a division. So I'm going to instead write it as divided by 4x squared over x squared minus 16. This and this are the same exact thing. This one's just ugly. This one's a little bit less ugly. So I always take these and rewrite them like this. That just makes me like more comfortable and it looks nicer to me. So we're going to start with our first step. We are dividing, so we're going to take the reciprocal of the second fraction and multiply. So that means my first one's going to stay exactly the same. But now I'm going to multiply the reciprocal. X squared minus 16 over 4x squared. So now once I have done that, so now I've done my first step. Now I can move on to step 2. So step 2 is almost, well, it isn't, it's not almost, it is exactly the same as step 1. We are almost entirely at the same spot that we were when we're reducing. So my second step is to completely factor all expressions, which just means factor everything on top, factor everything on bottom for both ones. So 12x, I can't really factor that further, but I can factor 5x plus 20. I can factor out a GCF of 5. And then x squared minus 16, I can factor to be x plus 4 and x minus 4. It's a difference of squared. And then 4x squared, I can't really factor. So then my last step is the same as my last step with reducing rational expressions. I would cancel any like factors. Again, factor is super important. So I look to see, do I have anything? And I can cross cancel. Multiplying it doesn't matter. And really what you can do is you can just imagine this as all one line and one problem, just like we were up above. And so now I can start to cancel. X plus 4, those can cancel. Now, let's think about the other ones. X minus 4, that can't cancel with anything. But let's look at the 12 and let's look at the 4. 12 really can just be put into parentheses. 4 really can be put into parentheses because that's 12 times x. 4 times x squared. So I can simplify this. 4 divided by 4 is 1, and 12 divided by 4 is 3. I can go one step further. I have an x that can essentially be put into parentheses, and an x squared, which can essentially be put in parentheses. And this is similar to what you guys were doing in last section. X over x squared, Well, those can cancel. X would cancel out and x squared would become x1. So my final answer, on top we have 3 times x minus 4. And on bottom I have 5 and x1, which I can just write as 5x. And that is my final answer. Now, to add kind of, up here, I said, always leave your answer fully factored, which is exactly how I want it to be here too. But also your answer should be one expression. So notice how I didn't leave them separate, because multiplying, we're just multiplying it to be one expression. So your answers should be one expression, fully factored. So if you had left it as like 3 over 5 times x minus 4 over x, I would not want you guys to do that. I'd want you guys to write it as one expression. Okay, so let's move on to 5. That's not dividing, it's multiplying. So we can ignore step 1 and move on to step 2. So what I want you guys to do is factor every single thing that you can. Factor tops, factor bottoms, factor as much as you can. And then I'm going to do it also. So pause me here, try it on your own, and then come back, check your work. Okay, so I fully factored everything. My top of my first one can't be factored. My bottom one I factored out of GCF. Top of my second one is a difference of squares, and bottom I factored out of GCF. So now that everything's factored, I can cancel out any like factors. So think on your own, what would you start to cancel? What would be something you would cancel? And if you're thinking x minus 1, that would be where I'd first start as well. X minus 1 and x minus 1 can cancel. Okay, then I think, can I cancel anything else? X plus 1, x plus 2, no, there's no other x anywhere. What about 15 and 5? 15 can be put in parentheses, 5 can be put in parentheses. There's no plus or minus attached to it. So I can actually simplify those. 5 goes both into both of those. So 15 divided by 5 is 3, and 5 divided by 5 is 1. And so now I just write it as one expression, fully factored. So 3 times x plus 1. Again, don't multiply it out. Waste your time. I don't need you to do it. It's fine. Nothing left here, and then x times x plus 2. Let's say you did multiply it out. If you multiplied it out and you multiplied it out correctly, you're good. If you multiplied it out and you multiplied it out incorrectly, that's where I'd mark you down. So that's where I'm saying don't multiply it out if you don't need to. And so that's my final answer. I always give it kind of a 1 over and look to see, is there anything that I missed that I can cancel? And there isn't here, so we are good to move on. Okay, so I want you to look at 6, and I want you to look and think, what would be your first step that you would do here? And if you're thinking, take the reciprocal of the second fraction and multiply, you would be correct. So my first part stays the same. X plus 2 over x squared plus 8x plus 12. But now I'm going to multiply the reciprocal, x squared minus 36 over 5x squared minus 30x. Okay, so now I am at the same spot that I was at 5. So what I want you guys to do is, I actually would like you guys to continue through with this problem, finish it all on your own. So simplify it as much as you possibly can. So pause me, try it on your own. I will kind of show step by step. Okay, so my first step was to factor. So I factored the denominator, the two numbers that multiply together to get me 12 and add to get me 8 are 6 and 2. I factored x squared minus 36. It's a difference of squares. And then I factored out a GCF from 5x squared minus 30x. Now I'm going to move on and keep going. So if you got there, keep going. So This one was nice. I liked this one because you can cancel a lot. X plus 2 and x plus 2 can cancel. X plus 6 and x plus 6 can cancel. X minus 6 and x minus 6 can cancel. We can cancel a lot, which I like those ones. So I'm looking, what's left on top? Well, nothing's left on top. So when nothing is left on top, what number can we always still put there? 1. And then that's gone, that's gone, that's gone. The only thing that's left is 5x. So this entire problem turned into 1 over 5x. And that is it. Okay, if you guys need to take a break, take a break. Pause me here, do what you need to do, come back, watch the rest of the video. We're going to get into adding and subtracting. That's going to be our last section, but if you guys need to pause me here, and then we're going to keep going with adding and subtracting. Okay, so adding and subtracting. Just like I did for the last one, I started with kind of like the hardest problem. I started with the hardest problem for adding and subtracting. So I wanted to incorporate every aspect because not every aspect is incorporated in all of these. So number 7, first step, whenever you guys are adding and subtracting, which you can tell you're adding and subtracting because of that in between, first step is to factor the denominator. Now, you may be thinking, why not the numerator? And I'll go over that in a second. Let's factor the denominators. So we have x plus 4 over that factored. So what two numbers multiply together to get me -2 and add to get me -1? That's going to be x minus 2 and x plus 1. And then minus, we're not touching the numerators at all, just looking at the denominator. X squared plus 2x minus 8. So that factors to be x plus 4 and x minus 2. Okay, so when we are adding and subtracting fractions, what is the one thing that you have to have the same before you can do anything? It's the denominator. So why we factored the denominator is to see what factors they had. And our goal, and this is our second step, our goal is to determine the common denominator and multiply the top and bottom so the denominators are the same. So, and really important, let's highlight that part. Make sure to completely multiply the numerators before moving on. And I'll go back over this in a second. So I look to see first at my denominators, and I look to see, do they have anything in common? And they do. They both have an x minus 2. But this one has an x plus 1, and this one doesn't. And this one has an x plus 4, and this one doesn't. So what we need to do is we need to get it so the denominators are exactly the same. We can't take away stuff, so we're going to add stuff. This has an x plus 1, so this one also needs an x plus 1. So I'm going to multiply the top by x plus 1 and the bottom by x plus 1. This one has an x plus 4, and this one doesn't have an x plus 4, so I'm going to multiply the top by x plus 4 and the bottom by x plus 4. We multiply the top and bottom because we're multiplying by 1, essentially. Anything divided by itself is 1. So if you're multiplying something by 1, you're not changing the validity or changing the structure of the problem at all. That's why you have to multiply top and bottom. So that highlighted part, make sure to completely multiply the numerators before moving on. That's what we're going to do. We're going to multiply x plus 4 times x plus 4. So that's just foiling. X times x is x squared, plus 4x is 8x, and plus 16. And then the denominator is now x plus 4 over x minus 2. over x plus 1 minus, and now I'm going to multiply here. So 2x times x is 2x squared. 2x plus 3x is 5x plus 3 over the same denominator now. So now they both have an x plus 4. They both have an x minus 2. They both have an x plus 1. And so now they have a common denominator. If they don't have a common denominator, you cannot do anything. So our next step is to combine like terms in the numerator, just like we would if we were adding fractions. If we were adding fractions and we had gotten a common denominator, all you do is just add the tops together. So we're going to do that now. Combine like terms in the numerator. Oh, someone's calling. Okay, so combine like terms in the numerator. If you are subtracting, which we are, I told you I'm involving every part in this problem. If you are subtracting, make sure to distribute the negative. So let's look at the top. We are subtracting here. So the thing that I'm saying there is before we combine like terms, x squared, 2x squared, all that stuff, we want to distribute this negative to every single term after it. So what happens is I have x squared plus 8x plus 16 minus 2x squared minus 5x minus 3. And now all over one denominator because they're the same. Of x plus 4, x minus 2, x plus 1. So now I can combine my like terms. X squared minus 2x squared is negative x squared. 8x minus 5x is 3x. And 16 minus 3 is 13. All divided by that same denominator, x plus 4, x minus 2, and x plus 1. So this next step is now we're at the same spot that we were in reducing or adding or multiplying and dividing. We completely factor all expressions, which the denominator is already factored. I'd see if I could factor negative x squared plus 3x plus 13, which I can't. It's not factorable, and you probably can't see this right now. Nope. So I move on to step 5, and then it would be to, again, cancel any like factors, which there are no like factors that I can cancel. That's my final answer. I'm just going to write it in blue. Plus 3x plus 13 divided by that entire denominator. Don't multiply this together. It would take you too long, and it's not worth your effort to me. And that is your final answer there. Okay. Take a minute. If you need to pause me here and go through that problem, go through that problem. If you want to go over more problems together, we'll do more practice with this a lot. Don't worry. But if you have questions, take the time now. Write it on a Post-it. What questions do you have? Where were you confused? Are you confused? What do you need help with? Make sure your questions are specific. The more specific you are, the better you're helping me, and the more you're helping your classmates too. Okay, let's look at 8. So 8 is 5x minus 4 over 3x plus 4 minus x plus 1 over 3x plus 4. So our first step is to factor the denominator. The denominators are factored. I can't factor those any further. My second step is to determine the common denominator and multiply top and bottom so the denominators are the same. But wait, the denominators are the same. So because the denominators are the same, I don't have to do all that hard stuff that I did up above. I can skip steps 1 and 2 because we already have common denominators. Yay! So see how I said I was starting on the hardest one and then ease up a little bit? I did. Okay. So third step, combine like terms in the numerator. If you are subtracting, which we are, make sure to distribute the negative. So let's distribute the negative to x and to 1. So really, we just have 5x minus 4 minus x minus 1 all over my denominator of 3x plus 4. And now I can just combine my like terms. 5x minus x is 4x. Negative 4 minus 1 is negative 5. And then 3x plus 4. And then my next step, completely factor all expressions. Can I factor 4x minus 5? Nope. Can I factor 3x plus 4? Nope. That's my final answer. Nothing I can cancel. Nothing I can do. That's it. Okay, let's try 9. First thing, factor the denominators. The denominators are factored. Nothing more that I have to do there. Now I need to determine the common denominators. So I first look, when I'm looking at the common denominators, first, are the denominators the same? And they're not. X minus 4 is different from x plus 3. I look to see, did they have anything in common? They don't. So all I'm going to do, this one has an x plus 3. This one has an x minus 4. So they need to be the same. So if this one is missing the x plus 3, I'm going to multiply the top. I'm going to squeeze that in here by x plus 3 over x plus 3. And then I'm going to multiply this one by what it's missing, which is x minus 4 over x minus 4. Make sure to completely multiply the numerators together before moving on. So 3x times x is 3x squared, and 3x times 3 is 9x over, I'm not going to multiply these together. We just multiply the numerators together. Plus 2x times x, which is 2x squared. 2x times negative 4 is negative 8x. And then all over x plus 3 times x minus 4. Are my denominators the same now? Yes, they are. Now I can combine like terms in the numerator. I'm not subtracting, so I don't have to distribute the negative. So I just have to combine my like terms. 3x squared plus 2x squared is 5x squared. 9x minus 8x is x. And then the denominators don't change. Okay, can I factor anything? I can. 5x squared plus x, I can factor out a GCF. I can factor out a GCF of x. And then the denominator is already factored. Is there anything I can cancel? And there isn't. So that's my final answer. If you didn't factor the top and you left the top as is, I would still give you credit. That's totally fine. So this is my final answer. Okay, let's look at 10. Okay, first step, factor the denominator. So that's what I want you guys to do. On your own, I want you to factor the denominator. Okay, so I factored. It's only the second denominator that needed to be factored. Two numbers that multiply together to get me 1 and add to get me negative 2 are negative 1 and negative 1. So now that I've done step 1, I move on to step 2. I determine the common denominator and multiply the top and bottom so the denominators are the same. Are the denominators the same? We have 1x minus 1, and then I have 2x minus 1s. So they're not exactly the same. This has 1. Those are in common. But wait, there's 1 extra here. So because there's 1 extra here, I have to multiply this one by x minus 1 and x minus 1. Now this one will have 2, and this one already has 2, so I don't even have to touch the second one. And now I need to make sure to completely multiply the numerators before moving on. So 3x times x is 3x squared. 3x times negative 1 is negative 3x. And then my numerator, or my denominator, is that x minus 1 times x minus 1. Okay, now that the numerators are completely multiplied out, I can now combine like terms. So I want you guys to try this next step on your own. Try this next step on your own. So pause me here, come back, check to see if you did it correctly. Okay, so hopefully your first step, because it's subtracting, was to distribute the negative. So that means we're doing 3x squared minus 3x minus x plus 4 all over x minus 1 times x minus 1. If you write x minus 1 squared, that'd be the fine too. Then we just combine like terms. Negative 3x minus x is negative 4x. And then nothing else could combine. I look to see if I can factor it. Do I know two numbers that multiply together to get me positive 12 and add to get me negative 4? And I don't. Some of you are thinking like, well, what about negative 6 and 2? But negative 6 times 2 is negative 12, not positive 12. So this is fully factored. There's nothing I can cancel. And this is my final answer. Okay, we are on the last problem. So the last problem is kind of looking at, so it's 11, is kind of similar to what we saw on 4. We had a fraction over a fraction. Now we have like a lot of fractions over one fraction. So to make this easier, I'm going to do exactly what I did on 4. I'm going to rewrite this as 1/2 plus 3 over x divided by x plus 3 over 4. Okay, now this is going to be really similar to 4. However, on 4, I didn't have any like separation on top or in between of two fractions. So I have to do one step before I can move on to doing what I did on number 4. And that one step of what I have to do first is I have to first make each side one fraction by getting a common denominator. So this is essentially combining adding and combining multiplying. So first, make each side one fraction by getting a common denominator. Now, this side is already one fraction. It's not separated like this one, so I don't have to touch this one right now at all. But what I do have to do is I have to deal with this side. So right now, I'm going to ignore this side completely and imagine like 1/2 plus 3x is something that we had in 7 through 10. So I'm looking, I factor the denominators. The denominators are already factored. And then I think, what's the common denominator? This has a 2, this has an x. So they have nothing in common. So what I have to do, I lost my pen. I wonder where it went. Oh, it was right in front of me. Okay. So this has a 2, this has an x. So we need to get this one and multiply this by x over x. And this one we have to multiply by 2 over 2. So 1/2 times x over x becomes x over 2x. And this becomes 6 over 2x. Now they have a common denominator, and now we can combine like terms in the numerator. We're not subtracting, so we don't have to distribute anything, which we wouldn't really have to anyways. So we'd have x plus 6 over 2x. Now this is one fraction. Now that this is one fraction, I can bring this problem down And now I can follow the same steps that I followed in 4. Dividing only, take the reciprocal of the second fraction and multiply. So this one stays the same, but now I take the reciprocal and multiply. 4 over x plus 3. Then I completely factor all expressions, which, let me write the 6 better. X plus 6 can't be factored for 2x, x plus 3, it's really factored. And then cancel any like factors. X plus 6 and x plus 3, those can't cancel. Those aren't exactly the same. What about the 4 and the 2? 4 can really be in parentheses. 2 can be in parentheses because it's 2 times x. So those are both divisible by 2. 4 divided by 2 is 2, and 2 divided by 2 is 1. So what's left? What's left is 2 times x plus 6, and on the bottom is x times x plus 3. And that is my final answer. And that does it for the notes. So we are done with R7. I know R7 was a little bit longer, but let me tell you, with guided notes, it was a whole lot faster. So if you guys have any questions, please make sure you guys are going through these and starring questions and getting them ready to ask in class. You've got to make sure you guys are taking ownership of your learning. You're asking those questions when you need it so we can go over them and clear it up. And that's it. So have a great day, and I will see you guys soon. Bye, guys.